Hey everyone, we're going to establish trig identities using the Pythagorean identities and the FOIL method, or actually a distributive method, or basic difference of squares. So basically we are going to work on the left side of the equation because it's more complicated, and I'm going to go ahead and write this tan as, I'm going to go ahead and write this as tan of theta times 1 over tan of theta. And this is a times, times cosine squared, no, it's actually a minus, minus cosine squared of theta. That should equal sine squared of theta. So, this equals 1. You put that in fraction form, multiply, and get 1 minus cosine squared of theta equals sine squared of theta. We know that this right here equals sine squared. So sine squared equals sine squared. And I'll show you why. Because we know that sine squared of theta plus cosine squared of theta equals 1. So if I solve for sine and subtract cosine squared of theta from both sides, that goes away and we get sine squared of theta equals 1 minus cosine squared of theta. And that's your Pythagorean identity, This is the same thing. I'm going to write this as sine of theta times 1 over sine of theta minus cosine squared of theta, which equals sine squared of theta. We're working on the more complicated side. This equals 1. We have 1 minus cosine squared of theta equals sine squared of theta. This equals sine squared of theta, which equals sine squared of theta. So there it is. And the next one, this follows the form of a minus b times a plus b. And we know that equals a squared minus b squared. So my a is secant, so I'm going to square that. And I'm going to put minus, and my b is 1. So secant squared minus 1 equals tan squared of theta. By definition, or by our identities, this equals tan squared of theta. So tan squared of theta equals tan squared of theta. So just remember on the identity sheet, secant squared of theta equals 1 plus tan squared of theta. So all we did is subtract the 1 from both sides, and we get that. Okay? Same thing for this one. This is going to be cosecant squared of theta minus 1 equals cotan squared of theta. So this is, by definition, cotan squared of theta equals cotan squared of theta. This comes from our identity that cosecant squared of theta equals 1 plus cotan squared of theta. And I just subtracted 1 from both sides and got that. Okay, the next one is the same thing. It's a plus b times a minus b. And we know this is a squared minus b squared. My a is secant, so square it. My b is tan, so square it, and I'm plugging it in there. And we know that this equals 1. So 1 equals 1. The reason we know that is because secant squared of theta equals 1 plus tan squared of theta. And all I did was subtract, I just manipulated this identity. If you subtract tan squared of theta from both sides, that cancels and you get this right here. Okay? And we have a few more. Same thing. We have cosecant squared of theta minus cotan squared of theta equals 1. This equals 1 by definition, so 1 equals 1. The reason this equals 1 is because cosecant squared of theta equals 1 plus cotan squared of theta. And I just subtracted cotan squared from both sides. Alright, and this one, I know that this 1 plus tan squared of theta equals secant squared of theta. That's your Pythagorean identity. So I have cosine squared of theta times secant squared of theta. Well, this is cosine squared of theta times 1 over cosine squared of theta. And if you multiply this, you get cosine squared of theta over cosine squared of theta. And it's obvious this equals just 1. So you get 1 equals 1 here. And this one, I know that this from the previous problem we did equals sine squared. And I know this equals cosecant squared. And we're multiplying here. So I just am using substitution in my Pythagorean identities. And I get sine squared of theta over 1 sine squared of theta. And this all equals 1. So you get 1 equals 1. And that's all. The next set we're going to do starts getting more complicated. So I'm going to call the next set starting where we're going to have to do some factoring and common denominator and all that good stuff. So what I'm going to do is call those the medium set. The ones we've done prior I consider the easy set. Thank you and have a nice day. Bye-bye.